You just learned the steps to determining empirical formula. And now we are going to apply these steps to two examples. We'll start with the first example in this video, and the second example will be in another video clip. So the steps that we have written here, they're going to make more sense as we begin to apply it to a problem. So let's take a look at our first example. The first example reads, X-ray diffraction is a powerful instrumental technique which is used to determine the arrangement of atoms within a crystal sample. Suppose an analysis was carried out on some mysterious yellow crystals, and the composition contained 46.4% lithium and 53.6% oxygen. You are then asked to find the empirical formula. So we're going to apply these steps. You're going to see that I'll apply these steps as I go through the steps on my board here. So I'm going to stop the share here, and we're going to see that I have it started here on the board, the percentages that we just discussed. So if we have a compound that is 46.4% lithium and 53.6% oxygen, we can use these mass percents in order to determine its empirical formula. Now remember, a percent always means per 100. So as long as these percentages total up to 100, we can assume that these percentages is the amount of grams of the element per 100 grams of the substance, okay, of the total substance. So then now these percentages we can assume to be in grams as long as these total to the total of 100. So always double check that it totals 100. So 46.4 plus 53.6 totals to 100. So we can assume that these are going to be, we can write these in terms of mass, okay? So we're going to write this as, I'm going to actually give myself space down here to do everything. So we're going to write this as 46.4 grams of lithium and 53.6 grams of oxygen, okay? And this is what makes up a total sample of 100 grams of the substance, okay, that we're looking to determine its empirical formula for. Okay, now the next step in our list tells us to convert each of the masses into moles, okay, because remember, compounds combine together in whole number ratios, and those subscripts represent the moles. So by converting this to moles, it's going to take us one step closer to determining the whole number ratio between the elements. Okay. So converting grams into moles of lithium, you need the molar mass of lithium. The molar mass of lithium is 6.94. per 1 mole of lithium. Okay. So that allows us to cancel grams to give us the amount of moles of lithium within the compound. Okay. So the moles here, when you calculate, will be 6.69 moles of lithium. Okay. Now let's do the same thing to determine the moles of the oxygen in the compound. So the molar mass of oxygen is 16.00 grams per 1 mole of oxygen. Cancel out your units of grams, and then you solve, and you should get 3.35 moles of oxygen. Okay. So now, once you've determined the moles of each element, now we're going to divide by the smallest number of moles in order to determine what the whole number ratio is between the elements. So we're looking to determine the mass relative to each other, okay? So just like we learned with relative masses, but what we're gonna do is we're gonna divide these. So I'm gonna divide both of these by 3.35. And what this gives us, when you do your calculation, you will get 2 moles of lithium per every 1 mole of oxygen, okay? So that's the ratio, the whole number ratio between the elements. Now, since these are the moles, remember, the subscripts within a chemical formula represents the amount of moles of that element within the substance. So as long as these are whole number ratios, we can write our chemical formula as Li2O. Okay. Now let's look at this chemical formula for a moment and recognize what type of compound do you think this is? This is a compound that contains a metal and a nonmetal, okay? So therefore, it is an ionic compound. So let's take a moment just to review naming ionic compounds, and let's see if we can name this compound. So what we have is lithium. Lithium is a alkali metal, so therefore, it has a +1 charge. So it has a predictable charge, okay? And then, so that means that we name it just as it is. So this is lithium. And then how do we name the nonmetal? We change the ending to IDE. So the oxygen becomes oxide, okay? And there's 2 lithiums because the oxygen has a -2 charge and the lithium has a +1 charge in order to balance the charges. So this compound has now been determined to be lithium oxide. Those yellow crystals have been determined to be lithium oxide.